Okay, we're going to try that again. I'm not sure what happened, but I got shut out of that at the end of that video. So I'm continuing on with number 12. Okay, again, just want to explain there that that is not going to be a probability distribution because when I added all the P of X values up, all the probabilities, okay, the probabilities must equal 1. Okay, so on this one, I would just say not a probability distribution. Okay, now the next thing I need to worry about here is, for example, if I move down to number 14, okay, I need, first of all, when I test those, when you plug them all into your calculator and add them up, understand that it might be just a little bit short or just a little bit long because of rounding. So on this one, I'm getting, so this one, 14 does equal exactly 1. Okay. So that's helpful. But if you get like 0.999, that's close enough. If we get 1.001, that's close enough. So one on either side of it, usually we can say, because if it's not going to be a probability distribution, it's not going to be just a couple little points. It's going to be a clear shortage or overage of 1. Okay, so keep that in mind. So, but once you've got that, okay, yes, this is a probability distribution, okay, then the other thing that I need to be aware of here is I need to find some additional values, okay? I need to find P of X, P times P of X times X. So I'm going to multiply these straight across, okay? So keep multiplying here. And okay, so once you get all of those multiplied, then what you want to do is you want to add those up. Okay, so by adding the 0.36, 0.196, 0.039, 0.004, okay, I got all of that to be 0.599. Okay, now that summation of all of those, that is your mean. Okay, and we said the mean is always going to be 1 decimal place more than my original values, so I'm going to round that to 0.6. So 0.6 is the mean for that distribution. Okay, now the standard deviation is the other one I need. So we said the formula for that is the square root of we're going to use, x squared times P of X. And then from that, we're going to subtract mu squared. Okay. So again, I need to make another column here. I need an x squared times P of X. Okay. So you're going to square x and then multiply it. Well, square 0, you still get 0, and 0 times anything, I get a 0 there. Okay. This is still going to be 0.36. 4 times 0.9098. I get 0.392 and 9 times 0.013 is 0.117 and 16 times 0.001 is 0.016. And then again, 0 here. So I'm going to take, when I add all of those up, I got so this is 0.885. Okay. So now I want to take these values and plug them in down here in this formula. So this summation of values here, 0.885 minus this value, the mu value squared. So 0.599 squared. Now notice I didn't use the number that I rounded. I went back to this other number that will give me a better result, a more accurate result. So I'm going to type that in. And then when I square root this, I'm getting 0.725, and again, 1 decimal place, that just rounds to 0.7. Okay, so those are the things you have to do. You need those extra columns. Okay, so when you take x times p of x over here and add them up, that's your mu value. And then when you take mu, take the x squared times p of x and add those up, that goes here, minus mu squared here, and then square root to get your answer there. Okay? So one more kind of like that. Help you out with some numbers on number 16. Okay? On number 16, here's what it kind of looks like. It is a probability distribution. Guys, come on. Thank you.
Is it present?
I don't know. We'll see. I got lots of stuff coming.
I need a reward.
Something not expensive, but they packed it in a funky package. Oh, it is.
Merry Christmas.
Well, I hope it's the one you wanted.
I need this. Oh,
Is it?
thank you.
Yep.
Day maker. Squirrels are coming up to eat now.
Okay.
Big fat one.
Okay, I'm recording again, if it'll let me. Okay, so again, we've got the x times p of x column. We've also got the x squared times p of x column. Okay, and I'm going to shortcut this a little bit. You can double check my numbers if you need to. Okay, so these are the totals. When I get done with my x times p of x and add them all up, you get 0.587. Okay, when I take x squared times p of x and find those values and add them up, I get 0.873. So for mu, here it is. Again, round to one decimal place. Mu is 0.6. My standard deviation is the square root of, and I take this number right here, the 0.873, and subtract mu squared. So again, I'm going to grab my calculator. And I get 0.727. It's actually 69, but I'm going to call it 0.27, and I'm going to round that then even more. That'll be just 0.7 there. Okay. Now, on 17 through 20, as you wrap up this thing here, they've given you a probability distribution. Okay. This time they're asking you to just use the table to answer some questions. Okay. So that's another way that you'll see these probability distributions used. Okay. On number 19, well, 17, you're going to find the mean and standard deviation just like we did above. Okay. And then using the formula for the mu plus 2 standard deviations and mu minus, this is for your finding your max. Okay. When you take mu or minus 2 standard deviations, okay, 2 times standard deviation, that's how you find your min. Okay. Now, so that they want the range rule of thumb on number 18. So you need to plug the numbers from 17 into that. Okay. On number 19, that's probably the one I want to look at here. So find the probability of getting exactly 7 P's. Well, if you go over to the table over there and find the number 7, okay, number 7 is 0.267. So that is the probability for that. Now, if it says find the probability of getting 7 or more, okay, that could be 7 or it could be 8. So 7 plus 8, the 0.2 and the 0.1, you get 0.367. And so when it says, is 7 an unusually high number of P's with green pods? Well, I'm gonna answer no to that because remember we talked about on the previous page that to be unusual, the probability would have to be less than or equal to 0.05. Okay, so going back to that 0.267, no probability not less than or equal to 0.05. Okay. And number 20 will be similar to that. Okay. So those are the things that I need you to be able to do out of section 2. Yes or no? Well, first of all, again, is it the variable continuous or discrete? Okay. Number 2, how do you determine if a probability distribution is, or if a distribution is a probability distribution? Okay. And then number 3, with a probability distribution, be able to find the mean and standard deviation. Okay. So those 20 problems is all you've got for that worksheet.